What if I told you the next big leap in electric cars won't come from a new motor or a faster charger, but from a change inside the battery so quiet you'd never see it, yet it could reshape everything? EVs are already impressive, but they still bump into the same walls: range anxiety, long charging times, batteries wearing out, and those rare but scary fire headlines. Welcome back! This is The Smart Side, where we learn how the world really works. Today we're diving into the silent revolution behind EEVs, solid-state batteries. What they are, why they matter, and what still has to happen before they become the new normal. Let's make this super clear from the start. Most EVs today use lithium-ion batteries, and inside every one of those batteries, you've got three key parts: one side, another side, and a middle layer that lets lithium move back and forth. That middle layer is called the electrolyte, and in almost every battery on the road today, that layer is a liquid. Now, liquids are great at moving ions quickly, so why change it? Because that liquid comes with trade-offs. It can be flammable, it can degrade over time, and it limits how hard you can push the battery, especially when you're trying to charge at high speeds or drive in extreme heat. So here's the big idea behind solid-state batteries. Replace that liquid electrolyte with a solid. That's the whole revolution in one sentence. But that one swap unlocks major benefits, while creating some very stubborn engineering problems. Let's talk benefits first, because this is why the industry is so excited. Benefit number one: more energy in the same space. In plain English, that means more range without making the battery bigger or heavier. And the reason solid-state helps is that it allows for a lithium metal anode. Here's the simple version. Instead of using graphite on the battery's negative side, you use actual lithium metal, which can hold significantly more charge. More charge in the same space usually means more miles on the road. Benefit number two: safety. Solid electrolytes are usually much less flammable than liquid ones, so the chance of thermal runaway, that chain reaction that leads to fires, drops dramatically, even if the battery pack gets damaged. Benefit number three: faster charging. Some solid electrolytes can handle much higher voltages without overheating. Translation: you may be able to add hundreds of miles of range in minutes with far less stress on the battery. Benefit number four: longer life. Solid materials are often more stable over thousands of charge cycles. This could mean your car holds onto its full range for decades, not just years. Now, if all of that sounds amazing, here's the obvious question. Why isn't every EV using solid-state batteries already? Because building them is hard in a very real-world way. It's not just about inventing a material in a lab. It's about making millions of batteries that work perfectly every day in the rain, the snow, and the heat for years. Challenge number one: contact. In a normal battery, the liquid electrolyte flows into every tiny gap, touching every surface. In a solid-state battery, you're pressing two solids together. If there's even a microscopic gap, ions can't jump across. Resistance goes up, performance goes down. Challenge number two: cracking. Batteries actually breathe. They expand and shrink slightly as they charge and discharge. Solid materials can be brittle. They can crack under that constant stress, and those cracks create weak points that kill the battery's lifespan. Challenge number three: dendrites. Think of dendrites like tiny microscopic metal needles that grow inside a battery. If they grow far enough, they can pierce through the layers and cause a short circuit. Solid state was supposed to stop them, but preventing them reliably at a massive scale is still a hurdle. Challenge number 4. Cost. This isn't a simple swap the liquid and you're done situation. It requires entirely new production lines and extreme quality control. One tiny defect can ruin an entire cell. That's why the first solid-state batteries will likely show up in premium models first, where the price of the car can cover those early manufacturing costs. Now here's where this gets really interesting. Solid-state batteries aren't just a bit better. They change how the entire car is designed. If you can store more energy in less space, car makers have a choice. Extreme range, lighter, more agile cars, or more room inside for comfort and safety, because the real enemy of EV adoption isn't the electric motor. It's inconvenience. People don't just want an EV. They want an EV that feels effortless. So when do we actually see these in everyday cars? It will likely happen in steps. First, we'll see semi-solid designs, batteries that use a gel or a reduced amount of liquid to capture some benefits now. Then, true solid-state will appear in limited high-end models for real-world testing. And finally, once the manufacturing scales, it will spread to the mainstream. So here's the takeaway. Solid-state batteries are a quiet change with loud consequences. They aim to make EVs safer, lighter, and faster to charge, just by changing one internal layer from a liquid to a solid. But the reason it's taking time is simple. Brief hold. It's not just chemistry, it's material science, it's massive scale manufacturing, and the fact that it has to work flawlessly for a decade of driving. Still, if engineers nail it, the EV you drive in the future could feel like a completely different category of vehicle, even if it looks exactly the same from the outside. If you enjoyed learning something new today, we'd really appreciate it if you hit like and subscribe. It genuinely means a lot to us, and it helps the smart side reach more curious minds like you.